Good day everyone, I am Sheila Jean C. Ilicano. In this video, I'm going to perform my mini thesis with the title of Evaluating the Effects of Wort Treatment Methods on the Germination Rate of Calamus merili and Calamus ornatus seeds by Jocelyn D. Alonte, Jerwin Cyril Sarande, and Roberto Jael Jr. Introduction. Background of the study. Rattan is one of the most important products in the country. It is the most versatile forest product because of its multiple uses. It ranks number 1 in the world market in terms of furniture, which is one of the most expensive furniture depending on its design and beauty. In terms of durability, rattan is regarded as second to wood because it is flexible and resilient, such that it can be designed in many ways. As of now, rattan is one of the exported Philippine products, such as rattan furnitures, and a dollar earner of the country. The country right now is facing a problem in terms of rattan production and supply in the market. The reason behind is the ever-degradation of our forest. 100,000 hectares of forest lands are lost every year. People are over-exploiting forest resources, including rattan, and not establishing plantations. Only few sectors of the society are concerned with the environmental problems and the continuous loss of its resources. The situation poses a greater challenge to people and to those who have the will to regenerate forests with rattan as intercrops of trees. We need to grow more rattan for us to have sustainable supply and sustainable rattan furniture industry. As a result of rattan loss in the forest because of overexploitation and over-degradation of our forest resources, the researchers has to find an alternative way to determine the best treatment in order to know the effective way in germinating rattan seeds in a shortest time possible. The findings of this study will be very useful to rattan planters and other sectors who have the interest to establish rattan plantations. Seedlings production is the most important and critical aspects of plantation establishments because when we can be successful in seedling production, we can have successful plantation of this forest commodity. The study is significant such that when the researcher will discover the best treatment for rattan germination in the shortest possible time, then many will encourage to produce rattan seedlings for plantations as a business. Hence this study. Objective of the study. Generally, the study aimed at evaluating the effects of wort treatment methods on the germination rate of Calamus merili and Calamus ornatus seeds. Specifically, the study sought for the following. Number 1. To evaluate the effects of different treatments on the germinability of rattan seeds. A. Helium removal. B. Tap water treatment. C. Hot water dip for 15 seconds. D. Controlled seeds without treatment. Number 2. To determine the best treatment that hastens the germination of rattan seeds based on A. Percent germination and B. Germination energy. Scope and limitation of the study. This study measured only the germination performance of C. merili and C. ornatus seeds. The conditions of the germinated seeds applied with different treatments during the study were recorded and analyzed. 4 weeks was the duration of the study. The study was conducted at the Northern Mindanao State Institute of Science and Technology from November 2008 to January 2009. Materials and methods. Locale of the study. This study was conducted at Barangay Ampayon, Butuan City, located specifically at Bautista Residence, Purok 3, Libuon Subdivision. Experimental design. The experiment was laid out in split plot design, 2-factor experiment with 3 blocks. Full plot treatments, C. merili S1, C. ornatus S2, subplot treatments, T1, HeLa removal, T2, hot water dip or soaking of seeds in 100C for 15 seconds, T3, water treatment, overnight seed soaking in tap water, T4, control seeds without treatment. Here's the experimental layout in split plot design with the 3 blocks. S1 contains T1, T2, T3, T4, T3, T4, T1, T2, T4, T2, T3, and T1, S2, T2, T3, T4, T1, and so on. Seed sourcing and extraction. The rattan fruits were collected at San Luis, Talacugon, Agusan del Sur. Only ripe rattan fruits were collected for seed extraction since only seeds from ripe fruits would give good germination percentage. The ripeness is checked by pressing the fruits in between the fingers. If the scaly cover gets detached easily, then the fruits are ripe enough for collection. Seeds were gently extracted from the fruit by crushing with the hands. The seeds were dried by spreading them in a sack and stored at shaded area for 2 to 3 days. Seed germination test. 40 seeds of palasan, C. merili, and 40 seeds of limuran, C. ornatus, in each block were divided into 4 treatments. Each block contained 4 subplots, and each treatment contained 10 seeds. The treated and untreated seeds were placed in a disposable container with wet cotton cloth spread at the bottom of the container. The wet cotton cloth served as germination media. The experiment was observed for 4 weeks or 1 month. Data gathering. Data gathered were as follows. Germination energy. Counting of days from sowing to emergencies. Percent germination. Percentage was computed using the formula. Percent G is equal to number of seeds germinated divided by total number of seeds times 100. Data analysis. Statistical differences among treatment means were analyzed using ANOVA for split plot and Duncan's multiple range test or DMRT. Result and discussion. In Simirile, first germination was noted in tap water treatment after 8 days. Daily emergencies were recorded thereafter. No germination was observed in HeLa removal and hot water dip. In C. ornatus, no germination was observed within the duration of the study. The researchers observed that all seeds treated in hot water dip in 15 seconds are died and were covered with molds. It shows that hot water dip is not appropriate method in the germination of C. merili and C. ornatus seeds. HeLa removal is also one way to hasten the germinability of the seeds, but it may take a long time before it emerges. Tap water treatment has highest percent germination of 80% among other treatments. It shows that overnight seed soaking in tap water is appropriate way to hasten the germinability of seeds. Control was the next in rank with 73%. There was no significant difference among tap water treatment and control. Hot water dip and HeLa removal had 0% germination for the whole duration of the study. Table 1% germination of C. merili and C. ornatus with 10 samples treatment. Treatments: HeLa removal, hot water dip, tap water, and control. Species total with 3 blocks, means percent. In the total, only the tap water and control has a number 24 and 22. Same with the means. Tap water is 8.00A, control is 7.33A, percent 80, 73. Table 2 comparison of germination means between species means. The species are the C. merili and C. ornatus. Total 23, C. merili, means 8, percent 80, while the C. ornatus has 0. Table 2 shows that C. merili had the highest percent germination, while C. ornatus had 0% germination. As we look to the table above, there is no seeds of C. ornatus had germinated within the 4 weeks study duration. There is significant difference on mean germination between C. merili and C. ornatus seeds. In Table 3, C. merili treated with tap water treatment has the highest percent germination mean of 8, while in control, the mean is 7.33. C. merili and C. ornatus seeds treated in hot water dip had 0% germination, as well as the HeLa removal. C. ornatus treated in tap water and control also had 0% germination. The analysis of variance yield a computed F value of 4.7838 among treatments, which is lesser than critical F value of 9.78 at 0.01 level of significance. It is only significant at 0.05. Table 3 comparison among treatment means on percent germination. Interaction, treatments X, species. Treatments T3XS1, T4XS1, T2XS1, T2XS2, T1XS1, T3XS2, T1XS2, T4XS2 means 8.00A, 7.33A, and the rest are 0.00B. It could be surmised that the difference lies only in control and tap water treatment only, which justifies the almost no significant difference at 0.05 level. Analysis of variance between species yields a computed F value of 14.2973, which is very highly significant both at 0.05 and 0.01 level significance. The significant difference lies on similarly treated with tap water equivalent to 80% germination and control with equivalent of 73% germination. The rest had zero germination. Table for germination energy of similarly seeds in 4 treatments with 3 blocks. TMNT, the HeLa removal, hot water dip, tap water treatment, and control. Species S1, S2, S1, S2, S1, S2, S1, S2. As you can see on the table, on December 22 to 30, only the tap water treatment has a number of 1. And December 31 to January 7, tap water treatment and control has a number of 5 and 4. Same also on January 8 to 15. Tap water treatment is 2, control is 3. 4 shows that the first emergence of seeds starts in similarly treated with tap water during the first 8 days compared to other treatment. On the 31st of December to 7th of January, tap water treatment again had the highest germination energy compared to control with a difference mean of 1 only. On the 8th to 15th day, control surpassed the tap water with a difference mean of 1. Similarly treated with tap water treatment had germination energy of 2 and control has germination energy of 3. Still no germination energy was recorded in HeLa removal and hot water dip. Thus, tap water treatment of similarly had the highest germination energy for the whole duration of the study. All treatments of C. ornatus had zero germination during the entire duration of the study. Summary, conclusion, and recommendation. The study evaluating the effects of 4 treatment methods on the germination rate of Calamus mirili and Calamus ornatus seeds was conducted last November 2008 until January 2009 at Bautista residence of Purok Tres, Libuon Subdivision, Ampayon, Butuan City. It measured only effects of 4 treatment methods on the germination rate of C. mirili and C. ornatus seeds and aimed at determining the percent germination and germination energy of C. mirili and C. ornatus seeds. There were 4 different treatments in 3 blocks, namely T1, the HeLa removal, T2, hot water dip soaking of seeds in 100C for 15 seconds, T3, tap water treatment overnight seed soaking in tap water, and T4, the control seeds without treatment. After a thorough observation, it was found out that in similarly tap water treatment has the highest percent germination of 80. Next is control, with percent germination of 73. HeLa removal and hot water dip had 0% germination. In C. ornatus, all treatments had 0% germination during the entire duration of the study. During the first 8 days, germination of similarly was noticed. Tap water treatment exhibits the highest germination energy among other treatments. On the 31st day of December to 7th day of January again, tap water treatment have the highest germination energy while control was the next in rank and HeLa removal and hot water dip had zero germination energy. On the 8th to 15th day, control superseded tap water treatment in the average number of germinants, but still tap water treatment has the highest germination energy. HeLa removal and hot water dip had zero germination energy. In C. ornatus, all treatments had zero germination energy during the whole duration of the study. Therefore, germinating of similarly treated in tap water treatment gave the highest percent germination and germination energy. But in C. ornatus, it may take a long time to determine the percent germination and germination energy. Conclusion. Based on the findings of the study, the following conclusions are drawn. Number 1. Calamus mirili or palasan species could be germinated with the use of tap water treatment, hot water dip for 15 seconds, and hilum removal as a way of enhancing germination were not appropriate methods. Number 2. Calamus ornatus treated tap water, hot water dip for 15 seconds, and hilum removal as methods of enhancing germination were not appropriate for the said species. Recommendation. Based from the findings and conclusion, the following are recommended. Number 1. When one is interested to engage in rattan seedling production project, specifically for the Cimarili or Palasan species, the best method of treatment is with the use of tap water only. Wet cotton cloth spread at the bottom of the enclosed container can be used as germinating medium. Number 2. Sea ornatus can be germinated with tap water or hilum removal, but it may take longer period. Patient is needed. Number 3. Sea ornatus needs further study on how to enhance germination at a shorter period employing treatments other than those employed in this study. This is Appendix A. Pre-germination treatments of Cimarili and Sea ornatus seeds. Treatments: T1XS1, T1XS2, T2XS1, T2XS2, T3XS1, T3XS2, T4XS1, T4XS2. Observation 1, 2, 3. As you can see the table, only the T3XS1 and T4XS1 has in numbers. To get the total, you only need is to add all the observation 1, 2, and 3, which is 8 plus 8 plus 8 is equal to 24. 14 plus 8 is equal to 22. And to get the mean, 24 divided by 3 is equal to 8. 22 divided by 3 is equal to 7.33. And the block total is 8. Observation 2. 8 plus 14 is 22. 3. 8 plus 8 is equal to 16. Grand total is 46. Grand mean 1.92. Appendix B. Analysis of variance ANOVA. Source operation. Block treatment. Error A. Species TXS. Error B. Total. DF 236133823 SS 12.3333 88.5000 37 88.1667 88.5000 49.3333 363.8333 MS 6.1667 29.5000 6.1667 88.1667 29.5000 6.1667 FE1 4.7838 14.2973 4.7838 tabulated F 0.05 4.76 5.32 4.07 0.01 9.78 11.26 7.59. And here's the images of Calamus mirili and Calamus ornatus seeds. Plate 1, Calamus mirili seeds treated with HeLa removal. Plate 2, Calamus mirili seeds treated with hot water dip, soaking of seeds in 15 seconds. Plate 3, Calamus mirili seeds treated with tap water treatment, overnight seed soaking. Plate 4, Calamus mirili seeds without any treatment. Plate 5, Calamus ornatus seeds treated with HeLa removal. Plate 6, Calamus ornatus seeds treated with hot water dip, soaking of seeds for 15 seconds. Plate 7, Calamus ornatus seeds treated with tap water treatment, overnight seed soaking. Plate 8, Calamus ornatus seeds without treatment. And that would be all for this video. Thank you.